Hi Leah, I'm going to try and make this video short and sweet, but you're always welcome to ask me questions or just email me if any of these don't make sense to you. I basically went through the video that you sent me today and wrote down all of the questions that you missed, but then I also put the other questions that we were talking about yesterday at the bottom, so we'll go through everything. So the first one is question 2 on the video, and this one's asking us to find the value of theta. The easiest way to do this is to kind of create, or the easiest way I think there is to do this is because it's a right cone. What you can do is you can create a right triangle where we know that this is 5 and this is 13. And then this angle right here at the top wouldn't be theta, but it'd be like half of theta, or theta divided by 2. Because we cut that top angle in half. And what we'll do is we'll solve for that angle and then just multiply it by 2. So, and then we know that this is right angle because we just cut it in half. So basically if I label my sides, this would be my opposite side and this would be my hypotenuse side. So the equation that uses opposite and hypotenuse is sine, so I'm going to use sine of theta is opposite over hypotenuse. I'm going to plug in what I know. So sine of theta is equal to my opposite side, which is 5, over my hypotenuse, which is 13. And then to find theta, I would do the inverse sign. So theta is equal to sine inverse of 5 over 13. So when I plug that into my calculator, I get 22.62, but like we kind of talked about this answer goes to this angle, but that's not the angle we're trying to solve for. We're trying to find the overall angle, and what we did originally is cut it in half. So to find the bigger half, we just take that 22.62 and multiply it by 2, which means my overall theta, or my final answer, would be 45.24 degrees. So that's your first answer. And the only reason why we can do this is because it says it's a right cone. As soon as I see the word right cone, I'm going to put a dot, kind of like I can draw a height. And then that creates a right triangle. And as soon as I see a right triangle, I can use SOHCAHTOA. Okay, so then let's look at question 3. So on question 3, it's asking you to just find the ratios. I think you're kind of close on these, just a little bit off. So the first 2 questions are asking you about angle P, which tells me what I'm going to do is I'm going to create, angle P is going to be my theta for right now. And now I'm going to label my sides opposite, hypotenuse, and adjacent based on that angle. So my opposite side would be right here, my hypotenuse would be right here, and my adjacent would be right here. Now, SOHCAHTOA, let me write it out, SOHCAHTOA basically says that sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. But then these questions aren't asking about those. They're asking about the flip-flop version. So the flip-flop of sine is cosecant. So cosecant of theta is hypotenuse over opposite. And then the flip-flop of cosine is secant. So secant of theta is hypotenuse over adjacent, and then the flip-flop of tangent is cotangent, so cotangent of theta is adjacent over opposite. So when I'm looking at secant of P, which is my first question, secant we know is hypotenuse over adjacent, which means my hypotenuse is R, and my adjacent is Q, so it'd be R over Q. Basically, you just did the opposite. And then the next one is asking for cotangent of P. So we can use the same setup. We already have it set up for angle P, so we can just use the same information. Cotangent is adjacent over opposite. So my adjacent side is Q, and my opposite is P, so it's Q over P. Again, you just flip-flopped them. Now on this last one, it's the cosecant of Q. So what I have to do now is, actually, I'm just going to do it in red. So instead of having theta be P, I'm going to have theta be Q, which just changes my opposite and adjacent. So now my opposite side is over here, and my adjacent side is over here. my hypotenuse stays the same because your hypotenuse is always across from the right angle, and the right angle never changes. So now if I'm finding the cosecant of Q, cosecant is hypotenuse over opposite. Your hypotenuse stays the same at R, but then your opposite side is now Q. Okay, so there's that one. Now let's look at basically like number 5 and 6. I didn't draw the graph because it was too hard for me to draw on here, but let me know if you want me to redo it or if something doesn't make sense when I'm writing through it. So the first thing I do is I find my midline on these graphs, and it looks like to me your midline is at -2. So like if I were to take that graph and basically just draw a line through y equals -2, it should be right in between, kind of right in the middle. If I folded that graph over, it would fold on top, not on top of itself, but it would like be right in the middle. So from y equals -2, I can count up to the highest point, and if I count up, I get 1, 2, 3, 4, or if I count down to the lowest point, I get 4, which means your amplitude is 4. So that the amplitude that you have is totally right. Your amplitude is 4, because that's the highest point or the lowest point from the midline. Now, the next question is asking you for period, and to find period, the general form for period on a sine function is 2 pi. So that normally tells us that we go from start to finish within 2 pi, but in this case, it looks like you started at 0, where x is equal to 0. You go up, and then all the way down, and then back up to the midline. And that back up to the midline would be at 1, 2, 3, 4 chunks in, or like 4 chunks from 0. And if each chunk is, or each tick mark is a pi sixth, that means my like period is 4 pi over 6, because I went 4 chunks in, and each chunk is pi sixths. Now I can simplify that to be 2 pi thirds. So my period is just 2 pi thirds. And I'm looking at the way that I'm getting that is just from the graph, because I'm looking at where it starts, and it starts at -2, like it's kind of like where it crosses the midline at -2, and then you go up, all the way down, and then back up to the midline. Wherever that hits the midline is where your period is. So now that we have that, we can write our equation. We know that our equation is going to start with y equals, we're going to have some sign, and then your amplitude goes in front. So we know the amplitude is 4, so that part's great. And then in front of your x in the parentheses, we have to have the period. Now, we know the period is 2 pi thirds, but if you remember, the number in front of the x is kind of like a b, and the general formula for period is 2 pi over b. So what I want to do is find that b. I don't know what b is. I know what my period is. I just don't know what b is. So if my period is 2 pi over 3, I can say period, which is 2 pi over 3, is equal to 2 pi over b, and find b. Well, that means that b is 3, just because they're both on the bottom, and then the 2 pi's are the same on the top. So that means inside my parentheses, this number would be 3 that's in front of the x. Generally speaking, the number when you write equations won't have a pi inside the parentheses, because your period always has pi's. And then you do have that -2 because the midline was shifted down 2. So you were really close on this one. It's just that the period got messed up, which changed your equation. Like I said, your period usually has the pi's, and then your equation doesn't have the pi's. Okay, so then if we're looking at question number 6, this one's similar. This time we're using a cosine function. Because you're using a cosine function, we have to find the phase shift, and the phase shift is totally right. You said that the phase shift is pi halves, which is correct. Basically, a cosine either starts at the top or at the bottom, like you start at the very max or the very min, and if we go from 0 to where the next max or min is, it's pi halves. So the phase shift of pi halves is great. Now, when I write the equation, I need to figure out what the period is. It looks like to me, or we need to find the amplitude and the period and all of that. So we know that the lowest point is at -2 and the highest point is at 8. So the midline will be right in between there, between -2 and 8, which gives me 3. So I'm going to just kind of write this stuff down. So the midline is at 3. Then if I go from my midline down to the bottom, or from my midline down up to the top, so I'm going from 3 to 8, that means my amplitude is 5. It looks like to me, when you answered this, you did it right, like you thought, but you wrote the amplitude as 10 because you were looking from the top to the bottom, but the amplitude is always from the midline to the top, or the midline to the bottom. And then to find the period, what I'm going to do is I'm going to find the very bottom of it. So for a cosine function, you go from bottom to bottom, or top to top. So the first bottom I see is at pi halves. The second bottom I see is at 5 pi halves. So the distance between pi halves and 5 pi halves is 2 pi. So that means my period is 2 pi. Because I'm looking for like the horizontal distance, or the x value between bottoms. And because the bottoms are at pi halves and 5 pi halves, I can just do 5 pi halves minus pi halves to get to 2 pi. And that's your period. So if I know my period is 2 pi, then what I can do is to find b, we use the formula period is equal to 2 pi over b, but my period is 2 pi, so I have 2 pi is equal to 2 pi over b. Well, that must mean that b is equal to 1, because 2 pi divided by something is 2 pi, well, 2 pi divided by 1 is 2 pi. So now that I have all of that information, we can start the equation. The only other thing that I wanted to show you is that because you start at the bottom rather than the top, oh no, wait, I lied. Let me think of that. No, but yeah, because you started at the bottom rather than the top, the equation has to be negative in the front. So our equation is going to be y is equal to negative, and then your amplitude, so 5. And then cosine, your period is 2 pi, so that b is 1, so we can say 1x, or you can just say x. Your phase shift is pi halves, which means we're going to say minus pi halves because you want pi halves to the right. And then you say plus 3 because your midline is at positive 3. That should be your answer. And yeah, okay, so that's your answer. All right, and then the next question that we need to talk about is question number 7. So question number 7 uses a couple of different things. It uses the unit circle, but so it also uses something called periodicity. Sorry, let me Google a unit circle really fast. So it also uses something called periodicity. Basically, if something's not on the unit circle, then you can either add or subtract 2 pi or 360 to get it onto the unit circle, and then find the unit circle values. So a good example of this is the first one, where you're trying to find cosine of 13 pi over 4. 13 pi over 4 is not on your unit circle. But what I can do is say 13 pi over 4 minus 2 pi, which when I put that into a calculator, I'm just going to take the pi's out. So I'm going to do 13 divided by 4 minus 2. And that gives me 5 over 4. So my answer would be 5 pi over 4. I take the pi's out when I do the calculator because the pi's are just going to give you a nasty decimal. And you can just take pi's out as long as you put them back in. So this is the same thing as saying cosine of 5 pi over 4, because all I have to do is take a 2 pi out. The reason why you can do that, you can either add or subtract 2 pi or add or subtract 360, is because of something called periodicity. Basically, the unit circle, once you go all the way around, you just go all the way around again, or all the way around again. So it doesn't necessarily change the values of the numbers the higher the degree gets, it just repeats itself. And so anytime it's bigger than 2 pi or bigger than 360, or smaller than 2 pi, you have to add or subtract 2 pi or 360 to get it into the unit circle, and then just look it up on the unit circle. So now that it's in the unit circle, we can say, okay, cosine of 5 pi fourths, I'm going to find 5 pi fourths, which is the same as 225 degrees. The cosine is the x value, which means that this is the negative square root 2 over 2. So that would be my answer right there. Now the next one is cotangent of 90. Now cotangent, cosecant, and secant are not on my unit circle, but because of what we kind of talked about up here, sorry, let me find it, right here where they're opposites of each other, we can use that information. So for cotangent of 90, I know cotangent is opposite of tangent, So I'm going to find the tangent of 90. Now the tangent of 90 is undefined, but really when we do like the tangent of anything is y over x. So at 90 degrees, the y is 1 and the x is 0. So I can say that tangent of 90, instead of saying undefined, I can say 1 over 0. Now to find cotangent of 90, basically I just flip-flop that fraction, so it becomes 0 over 1, which just simplifies to 0. So, or the other way to think about it is if you have something undefined, when you flip it, it'll always be 0. So the opposite of undefined is 0, the opposite of 0 is undefined. Okay, so the next one, the sine of 480, is really similar to the one we did where we were adding or subtracting 2 pi. 480 is not on your unit circle, so what I'm going to do is 480 minus 360. So when I plug that into a calculator, I should know this, but my brain's not working tonight. I get 120. So the sine of 480 is the same thing as saying sine of 120. Good news, 120 is on your unit circle. That's the same thing as 2 pi thirds. So I find 120 degrees on my unit circle, and then I find the y value because that's the sine, which means that my answer would be the square root of 3 over 2. Okay, and then the last one is secant of negative 5 pi thirds. So because it's negative, basically what we're going to do is we're going to take that number and do 2 pi minus that number, so 2 pi minus 5 pi thirds, and then that's the same thing. So in my calculator, I'm just going to do 2 minus 5 thirds, change it to a fraction, and I get 1/3. So this is the same thing as pi thirds. So I'm finding secant of pi thirds. So secant's not on my unit circle, but secant's the opposite of cosine. So what I'm going to do is find cosine of pi thirds and then flip the fraction. So cosine of pi thirds, I find pi thirds, which is the same thing as 60. Cosine is 1/2 because it's the x value. So secant of pi thirds would be the flipped fraction of that. So I flip 1/2 and I get 2 over 1, which simplifies to just 2. So the secant of pi thirds is 2, which means the secant of negative 5 pi thirds is 2 as well. Okay, now let's talk about the last question that you got wrong on the video is the same as one of the questions that we were going to work on anyway. It's the pentagon one, and I know I drew the pentagon like an idiot, but here we go. So for the pentagon, basically because we know all of the sides are equal, that means that all of the angles, like if I were to draw angles to the center of my circle, and again, I know I drew it like an idiot, but if I were to draw lines from each point where the pentagon hits the circle to the center, all of those lines would be equal, and all of the angles that they create would also be equal. So all of these are considered like theta, and they're all the same. So what I'm going to do is break out one of those triangles and say, okay, well, this is theta. And because I know the radius is 12, that means that all of the sides that go to the edges are also 12. So like all the red sides that I said that I've created are 12. The reason why I know that is because they all hit the edge of the circle, and the radius goes from the center to the edge of the circle. So we know that all of those are 12. Now the goal here is to find the perimeter, and which means basically what I'm going to do is solve for the bottom half of the triangle. And then when I find that, I can multiply it by 5, and that will give me the entire perimeter of the pentagon. So I hope that makes sense. If I find the bottom of the triangle, that's one of the sides of the pentagon. Because I know all of the sides are the same, I can just take that and multiply it by 5 to find the entire perimeter. So to do that, we can do it 2 different ways. Let me backtrack and say this. We still don't know what theta is, but we can find theta. The way that we can find theta is we know that all the way around a circle is 360 degrees, but we just broke it up into 5 equal triangles. So I'm going to do 360 divided by 5, which gives me 72. What that tells me is that theta is 72 degrees. So let me erase this theta right here and put 72 in there instead, because we know that all of those are 72 degrees because they're 5 equal triangles, which means that all of the angles on the inside should be the same. Okay, now that I have that, there's a couple of different ways we can do this. I just chose to use law of cosines. So I'm going to say x squared is equal to a squared plus b squared minus 2AB cosine of angle C, where your angle C is the 72 in this case. And then the A and the B are both your two perimeter, or your two radii, which are 12. So I can write this as x squared is equal to 12 squared plus 12 squared minus 2 times 12 times 12 times cosine of 72. When I plug all of that into a calculator, I did this earlier, so when I plug that all into a calculator, I get 199.00, which means that x, basically I just square root that, each side to get just the side, which gives me 14.11. So that's just the bottom of one triangle. But like we just talked about, to find the perimeter, which means it's one side of the pentagon. To find the perimeter of the pentagon, I take that number and I multiply it by 5. So I'm going to do 14.11 times 5, because a pentagon has 5 sides. And I end up with 70.53. And that is my answer. Oh, and honestly, I haven't been paying attention to the fact that it says round to the nearest 10th or round to the whatever number it is. So I haven't been doing that, but I also know that you know how to round. Okay, so there's only 2 questions left, and they're both on your orange paper that you sent me pictures of. The first one I'm going to talk about is the number 9, which is the Ferris wheel. It's actually a little bit easier than the other one, or at least I thought it was. So I didn't draw a picture of the Ferris wheel, but it tells us that the radius of the Ferris wheel is 15 meters and the center is 17 meters above the ground. So basically the entire thing is raised 2 meters off the ground. And it's asking how many meters above the ground is the point indicated by the arrow above. Okay, so here's how I did it. Basically, I counted the number of chunks there are, or the number of lines, from the center to basically the number of radii that there are, and there are 24. So if I know that there are 24 chunks, then I can do 360 divided by 24, and I get 15, which means that each chunk is 15 degrees. Now, that helps me, because then what I can do is I can kind of go draw a right triangle where that line, the hypotenuse is the line that's indicated. I know I didn't draw it very well, but where the arrow's pointing, I basically drew a horizontal line, and then I drew the line where the arrow's pointing and created a triangle. So now this is my right angle, and then the angle we're going to use is theta. Now that's not necessarily 15, because that's made up of more than one chunk. It's actually made up of 5 chunks. If you count from the horizontal line to the line where the arrow's pointing, there's 5 chunks. So what I'm going to do is 15 times 5, which is 75, which means that this angle is 75. Now the reason I do that is because now this line, the thicker red line that I'm drawing right now, is considered a radius, which means that it's 15. And then what I can do is I can find x, because that x is like your height, right? It's your height from the top to the bottom, not the bottom, but it's the height from the top to the midline. So what I'm going to do is start using use that to solve for x, and then we'll add a bunch of stuff to get the total answer. Because it's a right triangle, we're going to use SOHCAHTOA, which means I'm going to label my sides opposite, hypotenuse, and adjacent. And because I know that we want to find opposite, but we have hypotenuse, we're going to use sine. So I'm going to say sine of theta is opposite over hypotenuse. I'm going to plug everything in that I know. So I'm going to say sine of 75, because that's my angle, is equal to opposite, which is x, over hypotenuse, which is 15. To solve this for x, I'd multiply the 15 over, so I'd get 15 times sine of 75 is equal to x. Then I can plug that into a calculator, which gives me 14.49. Okay, so 14.49, if I'm looking at my Ferris wheel, 14.49 is kind of like this height, if this is my center. So what I have to do is add this height plus the height from the top to the ground, which this is 15 and this is 2, right? So I'm going to do 14.49 plus 15 plus 2 to get the entire height from the ground to the point where the arrow is located. And when I do that, I should get 31.48. So that's my final answer. Meters above the ground. Okay. Now this last one is number 8. And I chose to do this one last because it kind of blows. Or at least the way that I did it kind of blew. So bear with me here. Basically what I did is I said that these are two, instead of looking at it as a shape as a whole, I looked at it as they were two triangles that were sitting on top of each other, and they share this side between A and B. I named that side X. Now what I'm going to do is break the two triangles apart. Let me just draw them out really fast. So we've got D right here, A, B, 55X, and 35. And then I'm going to just kind of flip the other one around. So we've got B, X, A, 27, and 60. We also know that this is 121 degrees. What I'm going to do is use this triangle to solve for the side X, and then we're going to use that to go to backtrack and find the angle D. So we're going to use the second triangle here because we have more information about it. We know one of the angles. Sorry, I didn't say this, but we know angle C. So we're going to use law of cosines, which would be, I'm going to kind of write it over here. So C squared is equal to A squared plus B squared minus 2AB cosine of angle C. And then let's plug in what we know. So this is like our X squared because that's our side X, is equal to 60 squared plus 27 squared minus 2 times 60 times 27 times cosine of 121, which gives me the X squared is equal to, I plugged all of this into my calculator beforehand, so I'm not like a wizard at math, but you can plug them into the calculator too. So X squared is equal to 5997.72. When I square root that to just get X by itself, I would get X is equal to 77.44. Okay, so now that I know that X is 77.44, basically what I can do is go back to the first triangle or the top triangle and say that this is 77.44. I know that because the two triangles share that side, which means that it has to be the same length. Now that I have now I'm only concentrated on this first triangle here, or the triangle that I wrote on the left. And because I have all three sides and I want to solve for an angle, again, I can use law of cosines. So I'm going to write it out as D squared is equal to A squared plus B squared minus 2AB cosine of angle D. Basically, I just replaced the angle, like the C in my equation, with D just because it's using D. But you can, as long as you recognize that you're using you're solving for this angle and using this side, that's that's totally fine. Whatever makes the most sense to you. So then I'm going to say 77.44 squared is equal to 35 squared plus 55 squared minus 2 times 35 times 55 times cosine of D. I'm trying to find angle D, so basically I'm going to solve for cosine of D. To do that, I'm going to have 77.44 squared minus 35 squared plus 55 squared, because I'm going to take both of those away and subtract them. And then we're going to divide by negative 2 times 35 times 55. That's equal to cosine of D. So to find that, plug that into a calculator. When I did, I got cosine of angle D has to be equal to negative 0.4538. And then to find the actual angle D, we take the inverse cosine. So I'm going to have D is equal to cosine to the power of negative 1 of negative 0.4538, which when I plug that into a calculator, I get 116.98 degrees. So that one was definitely harder because you kind of had to go through a couple of steps to get to your final answer. But for the most part, again, you're just making some small mistakes, especially on the level 2s and level 3s. The level 4s are definitely hard, but it looks like she's repeating a couple of them. So even if you just review the ones that we just looked over together, like between this video and the stuff we did yesterday, you should at least get one of them. If not, maybe a couple or the majority of them. Okay, feel free to email me if you have any questions at all. If not, I'll just talk to you tomorrow. See ya.